It probably doesn't seem like too much of an effort to walk across the room and throw away a cup. But for this robot named Mitra, this is just the beginning. This robot is completely controlled by brainwaves.
Hollywood has come up with movies like Avatar and Surrogates and so on, and these are, Hollywood's fantasies about how the human brain can control devices. And so the question is, is that scientifically possible and technologically possible? And of course, the answer that I think most researchers working in the field would tell you is that no, it's not possible yet. And the issue is to what extent can we use signals from the brain to control external devices?
This non-invasive technology has immediate applications.
For helping people who are paralyzed and who are locked in, for example, and who cannot move parts of their body or they cannot even communicate in some cases.
Mike Chung is the actual human brain behind Mitra.
You can control an object or a robot by just thinking is very different experience. So I just try to imagine my arm moving and try to feel every single muscle, like how that moves or what kind of feel I get.
Mike's job on the team is critical. His thoughts control most of Mitra's actions.
So whenever you are actually making a movement like walking or you're using your hands, there's a particular pattern of brain signals that you can recognize on the surface of the head in terms of these EEG signals we're recording. But the same kind of signal is also generated when you imagine these movements, the same movements, like imagine moving your hand, for example, your left versus right hand. You get the same kind of signals. But what we're trying to do is to use these motor imagery signals to recognize these motor imagery signals and then to use them to make the robot move in a particular way.
Mike right now is wearing an EEG cap, and we basically just kind of lightly scrape the dead skin off of his scalp. And this is actually conductive gel. So what this does is it basically enhances the signal from the scalp so that it comes across cleaner to the electrode.
Mike's head is covered with electrodes. This cap on his head allows signals from the scalp to control Mitra.
These electrodes are recording signals from the scalp that reflect the activities of several thousands and thousands of neurons in his brain. And so he's going to use these two kinds of imagined movements to make the robot move in two different directions.
A computer attached to Mike records the electrical activity of nerve cell firings in Mike's brain and translates them into a language that Mitra understands. It sends the commands to another computer, which is attached to the robot. Mitra then receives the commands and makes its move very slowly. The simple task we started with, walking across the room and throwing away a cup, it takes about 10 minutes for the robot to do that. Mitra is actually pre-programmed with some basic tasks like walking and turning, but pretty much all of the other movements are controlled by this team. For Discovery News, I'm Casey D. Gardner.